Okay, we will go ahead and get started now. So hello everyone, and welcome to Following Breadcrumbs, Hunting Threats with Sysmon. Before we get started, a couple of housekeeping notes. This webinar will be recorded, and we will be sending out slides to all of you who registered. Our team will be sharing some links for the logs and malware examples for you to follow along during the demo in the chat box later. We will answer questions at the end of the webinar, so please feel free to type your questions into chat using the GoToWebinar control panel. And now a little bit about Binary Defense before we jump in. Binary Defense is a managed security services provider and software developer with proprietary cybersecurity solutions that include SOC as a service, managed detection and response, security information and event management, and counterintelligence. Our presenters today are Brandon George and James Quinn, and with that, I will hand it over to them.
How's it going, everyone? My name is Brandon George. I'll be your presenter today along with James. I am a senior analyst in the SOC. Currently, I work assisting analysts on a day-to-day basis along with customers when it comes mostly to monitoring. But I also work alongside James and Randy for any threat hunting needs that we have for our customers when they're not around. I currently maintain 2 threat hunting projects. I am a developer of the Sysmon modular fork on my own from Olaf Hartong, as well as a elastic threat hunting project called Elk Hunt. I am an avid runner and a coffee connoisseur. And with that, James, I'll send that your way.
So I'm a threat researcher for Binary Defense. And before I started at Binary Defense, I was an independent malware analyst for 2 years. I'm a member of the Imitate tracking group Cryptolemus. And in my free time, I play a lot of Smash Bros.
Okay, so things we'll quickly go over today. I want to give a brief introduction to what Sysmon is. We're going to go over the event types and how they're relevant into what we'll be seeing today. We're going to look at some use cases, and then we'll really get into the demo and analysis and field any questions anyone has. So what is Sysmon? So if you haven't heard of Sysmon before, it started back, I believe it was maybe in 2004, originally written by Mark Rusanovich, but when he came onto Microsoft, they have been actively developing that since then. It's part of the sysinternal suite, which I'm sure some of you use on a daily basis. It works alongside any of your security tools to just provide you a greater view that is loaded as a driver and logs all kinds of system activity you'll see. It is and was meant to basically expand the types of detections that aren't already seen in Windows Event Viewer or in Windows Event Logs, like your standard 4688 events and things like that. It provides you a greater view than what you would see previously. It also makes use of event tracing for Windows to easily trace how how events are coming to being, if you want to put it like that. And so you can, we'll see, you can take a look at, process create threads. It does some minor hooking for certain API calls, but ETW is the lifeblood of Sysmon and how it is able to string all of these logs together. So let's go over the event types that we're going to see today. We're going to focus on process creations. So that's event ID 1. 3 is network connections. We'll see Sysmon service state change. The state change is just when the driver was unloaded or if the service was stopped. We'll do event ID 7, so that's an image load. If a process is attempting to load maybe a DLL to try and utilize other functions that it doesn't already have. You can look at 12, 13, 14. Those are registry events. And then we'll see Event ID 15 for file string created. This recently got an update that I'll talk about in a little bit, and then event ID 23, which is file deletion. So event ID 1 is pretty simple in nature. It'll tell you that a process was created. It'll give you command line arguments. It'll give you the parent process, whether it's the GUID or the ID, as well as the current GUID and ID. There's not much to it. It can come in handy, especially when you're trying to utilize other tools that can help you kind of give you a timeline of what a process might be doing from a high-level view. It won't provide too much information, but it's enough information to get you started. So then network connections. This logs any TCP and UDP connections on the machine. It won't give you any really useful content, so maybe what was in the payload, but it will offer you the destination host name, in the case that it attempted to resolve some sort of domain name. The really useful thing here is if you say you have a suspicious process creation, you can take that process ID, and throw it in, some sort of log analysis tool, and you can say, okay, did this process attempt to make any network connections? And, again, just these two log types alone can provide you a lot of information that maybe you wouldn't have seen previously without having to, enable, without having some sort of other NetFlow data that you need to ingest from some of the log type. So the service state change, when the driver is unloaded or the service is stopped, it will generate its own events, very much like how you would see the logs being cleared on Windows. When a log is cleared, you're going to see, an event say, hey, the log is cleared. And that, if you see the service being stopped, that's, something you can immediately investigate and say, oh, okay, why was it stopped? What happened prior to this? As long as other logs weren't cleared previously, you can probably say, okay, well, was there any other process interacting with Sysmon at that point in time? Moving on to event ID 7, image loads can be very useful to you, so long as you're willing to put in the effort to try and filter them out. One example of this that requires a bit of work, can be very fruitful though, is looking for processes that don't normally interact with vault-CLI.dll. If Mimikatz is ever utilized, it's always going to call vault-CLI.dll. Now, I must put in a word of caution though. There are a lot of normal Windows processes that call vault-CLI.dll. So it's one of those things where if you have a config that it says, if there are any images that are attempting to load vault-CLI.dll from the desktop, app data, you can maybe consider syswow64. If any of those locations are included from the source image, maybe this is something that we can investigate and say, oh, okay, maybe Mimikatz was embedded in some sort of other process, or maybe it was being called by PowerShell, and you can look into that as well. So event ID 11, file create. File creations can be very helpful to you. One example of this is a while back, I was looking at Raccoon Stealer. When I let it run on my machine, just let Sysmon kind of look at what was happening, I noticed that in app data, it was attempting to write a bunch of files with credentials that it was trying to find in Chrome, Internet Explorer, Firefox as well, and it was writing to the files, zipping it up, and shipping it out. Another one was looking at SQLite.dll being dropped into those various application directories. So I can see all of that with event ID 11, so long as I'm including maybe parent directories or maybe specific directories that are related to those applications in the config. Very useful. but if you put it in a place where a lot of files are going to be written to, it's going to generate a lot of noise. So 12, 13, and 14 are all related to the registry. 12 is for object creation deletions, 13 is for value setting, and then 14 is for key and value renames. This can be useful when you see processes are attempting to interact with the registry in a way that maybe it's trying to edit the run key or the run once key. When you see that, you're not going to see the access, but you will see if it attempted to write a new object into run to run once, and we'll see that here in a bit as well. So I'm going to go over, we're not going to necessarily see this in the sample we're looking at today, but these are two updates that will have a lot of use to you in terms of phishing, as well as trying to cover tracks. Event ID 15 is for file create stream hash. What this does, when a file is downloaded, you'll be able to get the hash of a file's contents when it's being downloaded. This is useful if, say a user clicked on a phishing link and downloaded the document. If that is the case, what's going to happen is when that file is downloaded, you're going to get, I think, around 6 different events, but in one of them you're going to see a zone identifier stream that will tell you where the document was downloaded from. And that's going to be very useful to you when you're, maybe trying to triage a situation, say, okay, well, where did this document come from? You could look at NetFlow data, maybe from, if you're ingesting that, or if you're ingesting Zeek logs, things like that. But from an endpoint perspective, this is something that will be very useful to you if you're centralizing all of your logs. The last one is file deletions. When a file is deleted, you will be able to have that file archived in a directory that is only accessible by system. So you can use something like psexec to elevate yourself as system to, access that directory and then, download the sample and say, okay, well, what was being deleted. One of the jokes that I heard from someone previously is that, if this were to occur, saying an incident of ransomware, ransomware will go through and delete a whole bunch of files and then attempt to overwrite them. Well, if you run out of space, how can you deal with ransomware? But if in the case that an attacker is trying to cover their tracks, you're going to see that there's a file deletion, by a particular process if you're looking for that directory. It can be very useful. When this feature got added, I was exhilarated. There aren't many features that you think, man, I really wish I had this, but who would want this? And putting that in and including it at the start, I think is something that will be very useful to many organizations as long as they know how to utilize it appropriately. So I want to go over a couple of use cases and how they might be useful to you. If you have maybe detections in, say, a SIM, and say you're ingesting process creations, you can use that for early detection as well as seeing things as they happen. One of the many trouble spots in detections is that you need to, a lot of people will either start at the very end of a detection or at the very beginning, but sometimes missing things in the middle. If you have logs that are, being ingested from Sysmon to a SIM, there are many useful things you can keep an eye out for, as long as you're willing and or have the space to ingest them. If in the case that you have an incident, and we'll go over that, this can provide a lot of useful data to your responder, and they will be thankful that they have all of this data because, one, it'll help them triage what they're dealing with. It'll help you kind of take hold to say, okay, this is what we have, this is what we're dealing with, here's all the data that we can gather from, say, deleted files, here's the source, we know that in this case it's Imitate. all of this will be useful to your responder or your internal response team to help kind of figure out what the next steps are. One of the things that if you want to try and really visualize what is happening with a process, there are ways you can use, I can't even remember what the software is, but you can use visualization software to basically trace process and parent process IDs to kind of tell you, almost a hierarchical view of how processes are spying themselves. So if you want a sample of the logs, I'm going to drop these in chat real quick. Let's see, send to, there we go, my bad. Let's see if I can, let's see. It doesn't look like I can send it. Can someone else help me out here for a second?
Yeah, I think that link is already in the chat. Everyone should be able to see that. I can see it anyway. Okay,
perfect. So what you're going to have here is a big compilation of logs from an Imitate infection I just let run for a couple of days. I'll give you the time span and you can set up a view to kind of go from there. Or if you wait, we'll go to an Elastic Stack view and everyone will be able to see kind of what that looks like from a centralized point of view. Now, if you want the sample, this is a relatively new sample. I believe, I can't even remember what epoch this was from. The sample is zipped, and if you want to run it, again, this is a live sample that I believe is still able to run. Please use your own caution. The password is infected. I utilize this, today's the 29th. I started this, I executed this 2 days ago and was able to gather quite a bit of information that you'll be able to see and we'll go through together. So without further ado, let me transition over to the event viewer perspective, just so we can get started. We're just going to assume that your EDR hit an alert and say, hey, we found this being executed from the desktop, and it was able to drop itself in Sysmon 64 if I was running as administrator or in app data local. And so we'll start with the event viewer. So if you can see, let me know if you can. I have the process creation right here. It started at 11:09:37. Now I see that this, I've only filtered for the process creations just for the sake of what we're going to start out with. So I see that the file is 571.exe, and that'll be useful to me. So let me see if I can adjust the view. See, 11:09:37. Okay, and then I'm going to clear that out so I can look. While it waits. Okay, so that is all the way back 28th, so let's head down. Okay, so I see 571 is being executed. Okay, I'll ignore that. Okay, so file creation. So I see that it looks like this was ran as administrator because I can see this is being dropped in Sysmon 64, and it was written to this directory. So let's see what else we have. It looks like it also modified the file creation time. Let's see. So the creation UTC time was 15:09, and the previous was 21:57. So we know that there's some sort of file stomping going on here. Let's see what else. Okay, so it looks like it started the process. Then the file name is hnetmon.exe. Is there any file data? So we have the hashes. Okay, that's useful to us. Going. 0. Now, if you notice, if you look on we'll go back to the slides, but this has merely just replicated itself to a different directory. The hashes are the same, but it copied, started, and then in the next log, you'll see that it terminated 571.exe. And then this is not what we need. Going. It's compact. Nope. No. So just because there's already a lot going on, I'm surprised. Oh, I think I know what happened. So during this point in time, I also modified my config because I noticed there wasn't a event ID 23. What ended up happening was I wasn't looking at a specific directory, and I was missing file deletions from the desktop, and so that's why we didn't see a file deletion. Otherwise, if you are looking for specific directories for files being deleted, you would see an event ID 23, because after a user opens a maldoc, PowerShell gets ran, it drops it in a specific directory, and what's going to happen, and then it's going to delete that file and then rerun it from a new directory. It has to download it, so it'll drop it, start it, delete it, and then go from there. So there's a lot that happened in between this and what you'll see in the logs. There's a lot that you'd have to go through, and I'm not going to put you through all that. So I'm going to send you to the elk view. We'll start there. So what we have right here is I've set up a search for this date, and I've set it from the time we saw that first process creation to now. As you can see, I shut off the VM around 7:28, so we'll go from there. Now, if I wanted to know what was happening from this new process, what I would do is I would take the process of the hnetmon.exe, which, if I can get it for you, the process ID is 864. Now, if you've noticed, I have winlog event data process ID 864 or winlog event data parent process ID 864. The reason I did that is I want to know what's happening from this process, and I want to know if it spawns any other processes. In the case that it goes rogue and does something that's out of the norm. And I also included process PID and process PPID. I also had packet beats running in the background, but I've only set the event provider to Sysmon just because this is a Sysmon webinar, not an Elastic product showcase. So looking at what we have here, I've narrowed down the columns to event action. So I'm just going to tell simply what happened, winlog event data, what image, and the rule name. The Sysmon rules that I have set up are pretty much tied closely with MITRE ATT&CK. And so, you can say, okay, obfuscated file information, okay. And it really just depends on how the rule was written, depends on what MITRE tags. So, this might have just been a copy and paste and might not actually what I would consider to be, obfuscated file or information. But you can see we're getting the full message. So I see 571.exe. So it looks like that was executed. And then we see there was a file creation. We already know about that. And what we'll do is we can have the destination file name, I believe is what it's called. Target file name, there we go. And so I see it was written to file creation time and modified hnetmon.exe. Okay, that's about what we expected. And then we see the termination, again, what we expected. And then it goes from there. So we see that there was a network connection at 11:09:55. Now let's see what that remote information was. So I see the destination IP is 71.208.216.10. All right, so now what I need is I'm also going to pull out the destination IP as well as the destination host name. I just placed it for a second. QS will do that. There we go. Do that as well. Okay. So what we notice here is that we have creation, process creation, file creation, timestamping. The file that was written is now being executed. We're going to terminate the old process to try and hide our tracks. And along the way, we would have seen an event ID 23. And this is all happening in a matter of seconds. So we have 11:09:37, and now that 11:09:55, we're already seeing it attempting to call back to 71-208-216.10.ftmy.qs.net. And this is just one of the C2s for that day. And all we're going to see pretty much from here on out is just this QWest. One of the things that you'll notice is that this cuts out. So what we're going to do is we're going to find out why it did that. Move back. Look at this. So network connection, okay, it's about what we expected. Like this. So it just looks at the host name, just got cut and isn't being logged anymore. Now, most of the time you're going to be able to see the domain name that it's interacting with. If you have something like Zeek, if you have other products like Zeek, you may be able to get more information because if you noticed, I didn't show it in the columns, but this is all communicating over port 80. Yep, so destination port 80, and then you can see the source port is 5820. Again, it's just gonna be different. And so when you have this kind of information, you can kind of say, oh, okay, well, I can block that IP for one, try and cut the communication to prevent any other modules being downloaded, or any other malware being dropped, which again could be Quackbot or TrickBot at this point. And so what we also notice is that during the turn of the day around, so let's see, at 5:42 a.m., it transitions, and again, in under 20 seconds, it transitioned to a new C2, and this is what we'll see from here on out. And I believe we should get a host name for this, but that might not be the case. Let's look at the message. Now, however, we do see the ports have changed, so this is now communicating over port 8080. Again, I believe in packet beats, I got a host name for this, but this is why it's supposed to have varying log sources or for different types of information that you're going to need. And this is just with Sysmon alone. If we were able to detect another file being written, maybe it was QBot, maybe it was TrickBot, we might be able to see that, as so long as we are looking in the right directories. And this is where, malware reports from, updates from like Cryptolemus, if you want current IOCs, for what IPs and ports. I can't stress that enough. You need those two together. Otherwise, you may have some half-baked detections inside your SIM. So having both of these together will be useful to you. And so here, I'll pull up the destination ports as well. That way we can kind of see why just the IPs aren't going to be useful to you. So you notice 808080 and then 8080. So, making sure you have these together will be useful in the case that you have an incident, say, because I can't stress this enough, Imitate is not just your, ordinary mouse spam. It can do a lot of damage if you let it run long enough, because it's going to introduce so many other problems into the future. And so, understanding what it looks like from sources such as Sysmon will be useful to you, as long as you're willing to work with configs and really have the hard conversation about, okay, well, what kind of logs are we willing to ingest, and what other sources are we willing to implement that might offer us a more strengthened look into what our hosts are doing versus just NetFlow data. I know that isn't such an easy thing to do, especially when you have things like budgets, storage, computational resources, all at a strain, and especially right now. The implementation of Sysmon might be one of the most useful things you can do from an IR perspective, and it can be a helpful endpoint solution as well. Again, it's just knowing what to look for and trying not to cast too wide of a net, because I've seen Sysmon use up 500 megabytes of RAM, and if your endpoints don't have a lot of resources as it is, this is just going to be one more thing that you don't want to implement. So a catch-all is not the end goal of Sysmon, but enrichment. It's about how to make use of it, and knowing what your threat model is will help you say, okay, this is where we know the riskiest endpoints are going to be, and I want to deploy, Sysmon to my DCs. I want to deploy endpoint Sysmon to my risky users. So this is a really short view, but you can set up detections and say, okay, is there a file creation and then a deletion where the image is the same? That's an easy detection to say, okay, why would a process create and then delete its own image? That's something easy you can do. Or where you have a creation, write, deletion, termination from a suspicious location. So these are all things that you can consider when looking at Sysmon, but you will do yourself a huge favor just by implementing Sysmon by itself. So I want to head back to the slides because this wasn't too long.
Hey, Brandon, while you're doing
Yes.
that, let me give you some questions. First of all, people had trouble with downloading the malware sample from Google. What I did was I grabbed it and I put it up on Malware Bazaar.
Perfect,
So
thank you.
everybody should be able to get it there. If you didn't see it already, the link is in the chat. One of our attendees asked if you'd be willing to share any of your Sysmon config files. I know that you gave some really good examples of publicly available Sysmon configs with comments, and personally I'd suggest that's where people should start so that they understand fully what all the options are and what they mean, and have some good examples. But did you have any examples that you've put together that you'd also like to share, or do you just recommend people start with those public examples?
Yeah, so I'll say this first. First of all, any of the configs that I use here are all publicly shared. If you go to my GitHub page, and I can link that later. I recently just did a pull request for Olaf Hartong's Sysmon modular config, which includes all of the all, if not most, of the LOLBAS entries that you can see right now. I will see if I can send that in a bit. I want to have to kill the slides in order to do that. Actually, maybe not. So I'll link that page. But yes, I'd be happy to share that config once I can get it together. Okay. All right. So I will, Randy, I'll send that to you, and then and you can share that with everyone else. So if you want to, if you want to test that in a VM, it's not a config I would suggest anybody just goes out and deploys blindly. If you ever want to use a config, look at it carefully and try and consider what the implications might be for using that config. You know, some configs disable event ID 9, which is actually, I think it's not event ID 9. It's event ID 10, so process access. The raw access read as well as the process access might be disabled by default for performance reasons. I can't really blame you there. They're rare. Specifically, event ID 9 is more rare than event ID 10, but event ID 9 comes with a couple of hindrances when it comes to performance overall. There's going to be a blog, I can't remember who it was from, but someone's attempting to write a blog on how to really get the most performance out of Sysmon. And if that's ever the case, I'm sure I'll retweet it or something like that. But I would highly encourage you look at that GitHub page as well as Swift on Security. That's easily the most popular just because they put it out in one file, and you know, you can take a look, and it's very easy to digest. The great thing about Sysmon is it's not complicated to understand as long as you know as long as you know what everything means, you'll be able to piece together most of what's happening. Are there any other questions? Sorry, I kind of rambled on that.
While we're waiting for people to type in questions, James, did you want to go over any aspects of Imitate and some of the behaviors that we saw in the Sysmon logs, other things that might pop out or be useful for detecting?
Honestly, Brandon covered a lot of anything that I would talk about. Imitate isn't one to leave a lot of artifacts that would make it easy to detect. The most that you would be able to do possibly would be like looking for mappy32.dll loads by processes that aren't signed by Microsoft. Because it typically will, for example, when it's stealing email contacts, it's going to use that DLL, but it's going to spawn from a process that isn't a Microsoft signed exe. It's going to be just the normal Imitate exe. So stuff like that, just really weird image loads that shouldn't really be there. Brandon talked about Brandon, what was the example you gave in your slides? Can't remember
Which one?
The image loads.
For Imitate. So yeah, just unusual applications that aren't signed by Microsoft, loading bolt CLI.dll.
Yep, that one's really good. Another one that I've had a lot of good success with. This one isn't really Imitate specific, because Imitate doesn't really do this behavior. Is looking for the bits proxy.dll loads for bits admin, because that's the interface that's accessed when bits admin is used for COM objects. Just really digging into any of the COM object DLLs that might stand out and be suspicious.
One of the things that Brandon mentioned I thought was especially strong, having that detection for the simple sequence of events where a process starts and then shortly thereafter there's a file deletion event where that process that started deletes itself. That is so uncommon in normal software, but it is so very common, not just in Imitate, but across all malware that I have analyzed. It's almost a given that if it starts from an executable file, that it will delete itself at some point after it's installed and started up some other process in a more stealthy location that blends in better in the environment. So having just that alert based on process start events and file deletion events, and having enough detail to alert you when that pattern happens, I think that's really strong. I don't know, what do you think, James, Brandon?
No, that's an awesome detection, because I can think of so many samples just off the top of my head that do that process where they delete themselves. So that is an awesome detection. There's another one would probably be like just where it starts to drop random extensions into temp, or not temp, but like app data local, app data roaming. So, for example, Quackbot doesn't exactly use the most logical extensions for its config files. So you'll have like .cvx or something like that. And you can actually, if you have an ability to check entropy, you can do like an entropy check on file extensions. And I think there was a research article published about this that showed that the common file names typically have relatively low entropy compared to the uncommon and not exactly useful extension names that would be associated with malware. I know you can definitely do that with like file segments in an exe.
That's a good point too. Thank you, James. The next question that came in from Norman is, what is the proper way to download and utilize the Imitate malware that was provided to us in a sandbox? I'd say absolutely. And in fact, I'd even caution you, if you're not familiar with analyzing malware, just don't even do it at all. This is a live sample. It will definitely infect a computer. If you run it on a computer that you care about, the time would be now to shut that computer down, disconnect it from the internet, and completely clean it up, because it would be thoroughly infected by dangerous malware. So if malware analysis is something that you have at least some familiarity with, then definitely set up a sandbox where you can do this safely. We all use virtual machines for the most part. There's some malware that is virtual machine aware, like it'll detect that it's running on a VM and won't execute properly. There are some tricks that you can do to set up your VM so that it doesn't look like a VM, but you can't completely evade all malware detection of your VM. So after you've done those tricks, if it still doesn't work, I find it useful to have another physical machine set up that you can run malware on, but it's a whole lot of trouble to do that, because you need to make sure that machine is isolated, of course, and you have to rebuild it from like a good system image every time. Virtual machines are great because you can just restore them to a snapshot, and you have a lot more control over a VM than you do on a sandbox. So there's quite a few times when a sandbox just doesn't work, but if you open up a debugger and run the malware step by step in the virtual machine, you can modify registers and change return values from functions and other things so that the malware actually executes. Is there anything you guys want to add, Brandon?
Just a note on, just to go back a little bit on what James said. The big problem with malware nowadays is the lack of artifacts you may get. If you are enabling directories to be watched in Sysmon, you can collect more artifacts than I think you would ever really need. You'll have the original file that was written from the maldoc, or I guess from the PowerShell that was executed by the maldoc. You'll have that executable because it was deleted, and then you say, hey, maybe you have some sort of service running in the background to collect and check specific files from I call it the archival directory, from that archival directory to see like, hey, is this anything really bad? Is this anything really malicious? That will be useful to you. and you can really understand what you're dealing with. And again, you'll also be able to see, artifacts from maybe what was exfiltrated from that machine. Like having the file deletions won't catch things as they happen, but you will be able to understand how broad the incident is in terms of what maybe was deleted, maybe what was exfiltrated, and have that available to you. So I'm a huge fan of the file deletion feature, if you can't tell already, but it is something that if you want to know what was happening, inside of a VM, and you really narrow down the scope to say, okay, well, what was it trying to delete? Because if it's trying to exfiltrate, it most likely wanted to delete whatever it was trying to exfiltrate. So if you see that, oh, okay, this is trying to ship out all this information, that'll be useful to you, because then you'll get familiar with it and kind of know where to go from there. So that was my last little clip about that. It's very useful, very useful.
One more thing I'll add, for anyone who does not have a sandbox or a virtual machine set up to test this, if you'd like, I can send you a link to a online sandbox run on App Any, so you can see some of the events that happen. I'm not going to have as great a detail as if you have Sysmon set up, of course, but give you a rough overview if you don't want to do anything else.
Mm-hmm.
All right. It sounds like those are all of the questions. Let me send this link really quick on the chat. Is there anything else, Brandon or James, that you wanted to cover before we end the webinar?
I'm okay.
All good on my end.
Well, thank you both so much for your time, all the effort that you put into getting this ready and demonstrating that. Brandon, thank you for your open source work and sharing it with the community. I think that is great. And I know we're all big fans of Sysmon and its capabilities, but it can be overwhelming for some people approaching the decisions they have to make as far as configuration. And if you just deploy it without really thinking it through, it can generate so many events that it can just seem overwhelming. You're not even sure what value you're getting, even though it's hidden in there, buried in the thousands and thousands of events. So all of the community sharing is great and really helpful. Emily, did you have any wrap-up things that you'd like to bring up to let everybody know about?
Yeah, just thank you all for attending, and just as a quick reminder, we will be sending out the slides and the presentation after the webinar. That'll probably come out within the next day or so, and we hope that you all have a wonderful rest of your day.